Heredity Notes Part 3. Here we go. So, going back to Gregor Mendel, he established two principles that you definitely need to know. He established the law of independent assortment, and this means that traits do not influence how other traits are passed down, meaning that traits are inherited separately. So, for example, people with brown eyes are not more likely to have attached earlobes or brown hair, things like that, okay? Traits are inherited separately from other traits. And he also established the law of segregation, which means that each parent passes down a specific allele for each trait. So there won't be a situation where you get 2 alleles for eye color from dad and 0 from mom. Each parent will always give down 1. Now, let's talk more about specific genotypes. So up until this point, we've said that if you have, one copy of an allele, if you're dominant for something, that means that allele is more powerful than the recessive one, so on and so forth. That is not always the case. Some alleles are what we call codominant or incomplete dominant. So say, for example, in these flowers, we have a red and a white flower. Now, typically, we would think that, if red is dominant, most of these flower babies would be red. If white was dominant, then most of them would be white, so on and so forth. However, with incomplete dominance, we'll talk about that one first. With incomplete dominance, neither color is dominant. So if you mix red and white together, what do you get? Pink. All of their little baby flowers will be pink instead. And again, they're pink because red is not dominant and white is not dominant. Neither one is dominant, so they mix together. Human skin color works similar to this as well. Otherwise, would be random patches of different skin colors, and that's how that would work. Now, there is also the case of codominant. So codominant means kind of the opposite of incomplete dominance. With codominance, both colors are dominant. So they are both fighting for control. So red is dominant and white is dominant. And when you look at their baby flowers, they are red and white instead of just pink, instead of just red, instead of just white. Okay? Hair color is kind of similar to this too, because some hair, if you look at the actual individual hairs on your head, some might be blonde, some might be brown, some might be black. Okay, so it is not always just a case of simple, I'm dominant or I'm recessive. Sometimes they either will both be present or neither will be present, and they kind of mix together. Now, there are also sex-linked traits to consider. So the way that sex inheritance works in humans is that if you have 2 X's, you're a girl. If you have an X and a Y, you are a guy for the most part, barring any mutations or any weird hormonal things going on. So how this inheritance works is that all the eggs that mom creates will automatically be XX. And all of the all the sperm that guys create will either be an X or a Y. So it is the male that determines the future biological sex of your child. So if your husband ever complains that you don't have whatever, just remind him that it is his fault. So again, to recap, females will always donate an X to the future baby. Guys will donate an X or a Y. And this is why boys and girls are 50-50. Now, with sex-linked traits, these are traits that are located specifically on the sex chromosomes. So it'll be something that is specifically located on the X chromosome or something that is specifically located on the Y chromosome. What this means is that men are more likely to have certain mutations. So say, for example, that this X right here is mutated, and this guy here is the one that's born. This is the embryo that is conceived and happens and everything. Because there is no other X to cancel out this mutated X, this guy will automatically have the mutation. It's almost like it's dominant, even though it's technically not. Say if it was the girl who had happened instead, this one right here, this X here is not mutated, so it will counteract this mutated X, and the girl will be fine. This one, again, there is no X to kind of combat the mutated X, so this person will have the mutation. This is why a lot of guys are colorblind compared to females, because being colorblind in some capacity is an X-linked trait. It lives on the X chromosome, and it is more likely to show up in a guy because guys do not have another X chromosome to make up for the mutation.